All right. I guess people will file in. Welcome everybody. My name is Greg Caruso. I am director of the Patrick J. Waide Center for Applied Ethics. And this is part of our seminar series, which is part of our outreach efforts to bring intellectual speakers, scholars to the university community and to people in the wider community. So I'm just going to start with saying a word or two about what the Waide Center is and what we do, what our mission is, and then I'll introduce our speaker. The format will be 45 minutes of presentation, and then we leave roughly about 45 minutes for question and answers. The webinar is set up, unfortunately, where we can't see the attendees. But when we get to the question and answer period, you can use the raise hand function, and I will unmute you, and you can ask your question to the speaker. Or if you prefer, you could type in your question to the chat box, and I can read it to the speaker as well. All right, so just a little background on the Waide Center for Applied Ethics here at Fairfield University. Our mission is to advance learning, research, and dialogue about the leading ethical issues of our time. We have three core missions: curriculum, research, and outreach. The Waide Center offers a host of applied ethics courses across the university, including everything from business ethics to environmental ethics, to ethics in the community, ethics in education, healthcare ethics, and other applied ethics courses. We also support research by both faculty and students, and we organize a number of talks, events, roundtables, conferences, and this is part of our outreach. The seminar series is part of our outreach efforts to provide content and bring interesting speakers in to talk about controversial but also important ethical issues confronting society. And today's speaker is no exception, who will be talking about climate change and certain issues having to do with environmental ethics. The seminar series is a forum for building community and advancing research in applied ethics. It encourages jargon-free and supportive discussions that will be accessible to participants with serious interest in applied ethics, but who might be coming from a wide range of disciplines and backgrounds. Invited speakers in the series present a work in progress or recently published paper on topics related to applied ethics. And the best part is that at least half of the meeting is devoted to question and answers. I'm very excited today to have with us Marian Hordequin, who is professor of philosophy at Colorado College. She specializes in environmental philosophy, philosophy of science, and comparative philosophy. Professor Hordequin's current research focuses on climate justice, intergenerational ethics, the social and ethical dimensions of solar geoengineering, and relational approaches to environmental ethics. She's the author of Environmental Ethics from Theory to Practice and co-editor of Restoring Layered Landscapes. She's also currently finishing a third book, co-authored with Dan Shahara, entitled What Should Individuals Do About Climate Change? A Debate. So, and I should also mention she's president of the International Society for Environmental Ethics and associate editor for the journal Environmental Ethics. I am very excited to have with us today Marian Hordequin, and I will kick things over to you so you could share your screen. So thank you for being here.
It's great to be here virtually. So thank you for the invitation. And I want to thank Professor Caruso for hosting this, and also the Waide Center for organizing this whole series. So today I'm going to talk about climate change, geoengineering, and risk. And I want to mention that especially the latter part of the presentation is based in part on collaborative research and a draft paper with colleagues Sonia Klinsky, James Risby, Shivan Kartha, and Ambush Sagar. Okay, so most of the talk is going to be about something called climate engineering or solar geoengineering. But I want to start by framing this in relation to climate change, because we wouldn't be talking about geoengineering at all if it weren't, I don't think, if it weren't for climate change. So I think, as is well known, anthropogenic climate change is happening and its impacts are significant. So those include more severe storms, like the increased intensity of hurricanes and more frequent hurricanes that we're seeing. We're seeing glacial melting, also more intense and frequent wildfires, flooding, drought, all sorts of impacts locally and globally. So climate change is expected to have really significant impacts in the future, but also those impacts are with us today. And I just want to mention, just by way of illustration, an example from my hometown, or what's currently my hometown of Colorado Springs, Colorado. In 2012, we had a huge wildfire that was fanned by intense winds and exacerbated by really hot weather and dry conditions. It came quickly over the ridge and destroyed 346 homes. 2 people were killed in that fire, and over 32,000 people had to evacuate their homes. The following year, we had another really significant wildfire, basically in town or at the north edge of town, the Black Forest Fire, which destroyed 500 homes, and 2 people were killed in that fire. So I think it's likely that if you think about climate change, I sometimes ask my students, how have you been impacted by climate change? And sometimes their initial response is, oh, I haven't, like one of my students said, oh, I haven't been affected at all. I mean, I've only had to evacuate like 2 times from my house because of wildfire risk. I was like, well, that's affecting you, so climate change impacts are now pervasive enough that almost everyone on the planet is feeling the impacts in some way or another. And we know that climate change is driven primarily by the increase in greenhouse gases in the atmosphere. And this is just a slide showing sort of how unusual today's concentrations are of carbon dioxide in the atmosphere are in relation to sort of background conditions going back hundreds of thousands of years. So, okay, yeah, sorry. So given this issue of climate change and the significant impacts it's having, I think there's an imperative to respond in some way. I think that's something that there's fairly widespread agreement on, and obviously under the UN Framework Convention on Climate Change, which was established in 1992, countries around the world have been discussing climate change, trying to come to agreement on what the appropriate responses might be and moving forward on those responses. The central pillars of climate change response for a long time have been what's called mitigation and adaptation. Mitigation involves reducing the concentration of greenhouse gases in the atmosphere in order to stop driving climate change or reduce the climate forcing that's leading the planet to warm. And adaptation involves making changes in institutions, infrastructure, agriculture, and so on to respond to a changing climate. And to respond to climate change ethically, I think requires, very roughly 2 things: a focus on harm reduction and a focus on fair distribution of burdens and benefits. I think is well known, the impacts of climate change are not distributed fairly. Some of the nations that have been the largest emitters are both physically less impacted and also more capable of adapting. And some of the countries and regions that have contributed the least are some of the most hard hit. So a lot of the discussions around climate responses are thinking about how to distribute the burdens of mitigation, the burdens of adaptation, and also there have been discussions about how to compensate for climate losses and damages that are happening now and that will continue to happen in the future, because the amount of greenhouse gases we've put into the atmosphere basically lock in a certain amount of climate change for decades to come, even if we do really substantial work to mitigate. And if you've been reading the paper, I think, and following things, you're probably aware that under the Paris Agreement, there are goals to keep climate warming under 2 degrees Celsius and aspirationally under 1.5 degrees Celsius. but we're not really on track to meet those goals. And there's pretty serious concern that that we're going to globally exceed the 2-degree threshold. Climate scientists are, and others are particularly concerned about how there may be climate tipping points associated with increased warming that set off chains of events that significantly exacerbate the kinds of impacts that we're already seeing. So in light of that, people have started to discuss another possible additional response to climate change. Scientists generally agree that this possibility is not one that could substitute for mitigation or substitute for adaptation, but might be a supplement. And that possibility is goes by multiple names, but it's often called geoengineering, sometimes also called climate engineering or climate intervention. And these are basically intentional, large-scale efforts to manipulate global climate to counteract or compensate for anthropogenic global climate change. And as I mentioned, it goes by multiple names. Climate intervention is becoming more common as a term to refer to this suite of technologies. Geoengineering or climate intervention actually includes many possible technologies, not just one, but they're typically grouped in 2 categories. The first is carbon dioxide removal, strategies that pull carbon dioxide from the atmosphere. Carbon capture and storage, for example, is one example, or direct air capture of carbon dioxide. And then the other bucket, or the other variety of geoengineering or climate intervention, is known as solar radiation management or solar radiation modification. This is also called solar climate intervention or solar geoengineering. And for most of the talk, I'll refer to it as solar geoengineering, but that's basically, I'm using that synonymously with SRM. So the technologies that I have in mind in this talk are global scale technologies that involve modifying solar radiation to help compensate for the effects of climate warming. And specifically, I'm interested in a technique called stratospheric aerosol injection. So let me say a couple more words about geoengineering generally, and then I'm going to talk a little bit about those specific techniques that will be the focus here. So even though the idea of geoengineering was sort of bandied about in the 20th century, in the late 20th century, nobody, or not nobody, but very few people took it seriously until sort of the first decades of the 21st century. In 2009, the Royal Society came out with this report you see on the left, Geoengineering the Climate, Science, Governance, and Uncertainty, which was a really important kind of landmark report in opening further discussion and dialogue on this issue. There were later reports, such as some reports by the 2 reports that you see sort of center bottom from the National Research Council, National Academies of Science, Engineering, and Medicine. And then on the right, you see this Reflecting Sunlight report, which I was a committee member for, that was released in 2021, focusing on providing recommendations for solar geoengineering research and for governance of that research. So the point of this slide is to sort of suggest that although this topic, even doing research on this topic, remains intensely controversial, there are sort of more mainstream actors and institutions and members of the scientific community that have been getting involved in this area and pursuing research in this area and sort of thinking about how research should proceed, whether it should proceed, and under what kinds of governance structures. Okay, just a little bit more to give you a sense of the specific technologies and how they might work. with respect to solar geoengineering. Basically, the idea of solar geoengineering is that it seeks to offset climate warming by altering the Earth's energy balance, typically by reflecting a small portion of incoming solar radiation back into space. So this isn't actually doing anything to really directly change the concentration of greenhouse gases in the atmosphere, but it's trying to help compensate for the warming greenhouse gases create by reducing the amount of solar radiation that reaches the Earth. And there are a few different strategies. The two main ones that are most well researched and most often talked about are stratospheric aerosol injection and marine cloud brightening. Stratospheric aerosol injection basically would involve releasing tiny aerosol particles into the upper atmosphere or the stratosphere, and those would have a reflective quality, bouncing solar radiation back into space. The idea for stratospheric aerosol injection is based in part on observations from past volcanic eruptions, which have released large numbers of small particles into the atmosphere and actually created observable cooling effects for a year or so following large eruptions. The other strategy is called marine cloud brightening, and that basically involves increasing the reflectivity of low-lying marine clouds by the idea is basically to spray a fine mist into those clouds that would increase their reflectivity and also potentially their longevity. There are some other approaches that have been talked about, like putting mirrors in space to reflect sunlight, but those are not currently considered especially feasible alternatives. Okay, so there are a number of arguments in favor of at least doing research on and considering these kinds of approaches to be a potential component of a climate response. And some of the arguments are that, mitigation and adaptation based on the sort of tracks we're on may not be sufficient to avert really serious, dangerous climate change. Some people have argued that solar geoengineering might help buy time, cooling the planet relatively quickly and providing time for economies to decarbonize, to shift away from fossil fuels, since that's not something that can happen overnight. This has also been framed as an insurance policy in case, climate change gets really bad, whatever really bad is, and also in association with the idea that it might be valuable to arm the future, provide sort of a technology for future generations that could help them respond to really bad climate change. And then often this is also framed as a kind of crisis response or a last resort if climate change, if it seems like tipping points are sort of we're coming to the brink of a point where we're going to face some really significant tipping points in climate. So those are some arguments in favor, at least in favor of, a lot of proponents say, at the very least, we should try to learn more, and additional research may help clarify whether these strategies are viable and whether it's possible to engage in solar geoengineering in a way that's safe, moderately safe and moderately effective. There are also a lot of concerns about solar geoengineering. One of the chief concerns is that it might, even the possibility of solar geoengineering, this possibility that we could use some kind of technology to relatively rapidly cool the planet, might reduce incentive to mitigate emissions. Like people might think, well, we'll just, geoengineer our way out of the climate problem. And that would be non-ideal, I would say, because it's pretty much no scientist believes that we could geoengineer our way out of the climate problem. Like, we can't keep adding greenhouse gases to the atmosphere, ad infinitum, and just compensate by reflecting more and more sunlight. It's just, that's not going to be a good solution or a viable solution at all. The other thing is that because solar geoengineering does nothing to remove greenhouse gases like carbon dioxide from the atmosphere, ocean acidification associated with higher levels of CO2 in the atmosphere would continue, even if people use this technique. Lots of potentially unintended environmental consequences, like we don't understand very well regional effects on precipitation and whether things like South Asian monsoon could be disrupted, and so on. Big governance challenges, and that's going to be something I'm going to talk more about today in the rest of this talk. And then also significant concerns about justice and fairness, like could this technology be developed and deployed in a way that was fair, and what would this even look like? There are also really significant geopolitical risks, risks of unilateral geoengineering, geopolitical conflicts, or counter geoengineering. Another concern has to do with phasing this out. For example, if geoengineering were to begin and greenhouse gases continue to accumulate in the atmosphere, and then there was a sudden cessation of geoengineering, there would be like a very massive climatic effect to that sort of removal of this masking effect, and that would be quite dangerous. There are also worries about that this technology would just amount to kind of passing the buck on climate change to future generations and not investing sufficiently in doing what we need to do to reconfigure away from fossil fuels now. And then some kind of fundamental questions about whether humans should even be meddling in this way with the global climate at all, and whether this amounts to a kind of exacerbation of existing patterns of human domination of nature and hubristic ways of relating to the earth and to the broader world. So I think, as this like list of concerns that I've laid out suggests, geoengineering is not just a matter of sort of like getting the science right. It's not just a scientific issue. There are really important physical impacts associated with different solar geoengineering technologies and approaches, and we definitely need to study and understand those. But there are also a whole suite of other kinds of impacts and considerations that need to be studied from a multidisciplinary and transdisciplinary approach, including ecological, human health, social, political, and economic dimensions, ethical and justice dimensions, and so on. And then it's also really important to be thinking about how these strategies might interact with other climate responses, and also process-related considerations, like who should be involved in solar geoengineering research, development, and decision-making, and how. So here I just want to pause and say that sometimes the discussions and debates over geoengineering are framed as like, should we do it? Should we not do it? Or should we do research, or should we not do research? And I often think that obscures some of the really important questions about, like, if we're going to do research, how should we do it? How should it be governed? And as these different possible ways of doing geoengineering are explored, questions of how to proceed, which aspects of the which technologies might be most viable, and what processes should be used to make decisions about them. All those things I think are really important to consider. So here I just do want to give a small shout out, I guess, to the Reflecting Sunlight report that the National Academies of Science, Engineering, and Medicine put out in 2021, because I think this report actually did advocate for a multidisciplinary and transdisciplinary approach to research. And the research agenda that's laid out in that report is not just a natural science or physical science research agenda. It's a research agenda that includes questions of policy, economics, social science, public perception, ethics, and justice. And the idea there is also that research would be partnered with governance, and also with public engagement from the beginning, and in a way that was iterative over time and could lead to, ongoing assessments and revisions of the program, and would include exit ramps. So rather than being sort of a linear kind of goal-directed research program with a sort of expected endpoint of using these technologies, the idea here was that that research would be about sort of learning more and considering, as we learn more, whether additional research is warranted or not warranted. Like maybe we learn through research that this is just a bad idea, and there should be points in the research program to ask that question and to exit if needed. Okay. So I think one of the points that I want to underscore here is that like the pursuit of solar geoengineering is not just a scientific or a technological experiment. It's also sort of a global social experiment. And there are some pretty significant risks that are associated with the social dimensions, not just with the sort of technical dimensions. One worry here, sort of channeling work of philosopher Stephen Gardner, is I think crystallized in this question: how likely are we to do the right thing with respect to geoengineering if we've not been able to do the right thing in response to climate change? So, for decades, we've actually known that mitigation, reducing greenhouse gas emissions, moving away from fossil fuels, like, is critical. There's actually been like pretty strong international agreement that that needs to happen, but we've not been able to really make it happen at the scale that's needed to reach the goals that have been set internationally. So there are questions about, even where there's sort of a shared goal and we sort of know how to get to that goal, we haven't been able to do it. And so there are big questions about something as controversial as geoengineering, whether we'll actually approach this in a way that's, ethical and just. So, as I've already indicated, solar geoengineering, including just research itself, is quite controversial. Some people have argued for a non-use agreement, which would actually include a sort of freeze on research investment and development of solar geoengineering technologies. Others have argued that there's actually an ethical imperative to research solar geoengineering because it may be needed to alleviate some of the worst effects of climate change for the most climate vulnerable people and regions in the world. And then there's also been really significant controversy over outdoor experiments. We can talk about those later if you want, but most of these basically all of these experiments were very small scale experiments to try and understand things like, do we have the capacity, like how do aerosols behave in the atmosphere when we release a very small quantity of aerosols, like a kilogram or something like that? Or does this way of delivering aerosols to marine clouds could it actually work? Do these nozzles work, and so on? So these are very small scale experiments, but they have prompted like significant sort of social response and concern. And I think that's in part because people are concerned not only about the immediate physical effects of these experiments, but about their role in a larger program of technological development. All right. One challenge for governing emerging technologies like solar geoengineering is sort of encapsulated in what's called the Collingridge dilemma, which is the idea that like during the early stages of a technology, when it's maybe easier to set up governance, not enough is often known about the technology and its potential consequences to warrant controlling its development or to know how to control it. But then by the time the consequences are apparent, control is costlier and more difficult. So this, I think, is a dilemma that emerges in relation to solar geoengineering as well, but I want to suggest that we should try to start governing in the early stages, and that is going to be significant in terms of the way risks are managed and approached in relation to solar geoengineering. Okay, so how might we manage risk and uncertainty associated with solar geoengineering research, development, and any potential future use? I think for one, like this is not a risk-free, these are not risk-free technologies in any sense of the word. There are inevitable risks associated and inevitable uncertainties, and these will not be fully resolved by research. We just will never know all the risks. We only have like one planet, and most of the research on this in this area so far is based on climate modeling, basically computer modeling, and even small scale experiments can't fully capture the kinds of dynamics we would get at the global scale. So there are multiple approaches to managing risk and uncertainty. One approach is called risk-risk trade-off analysis, which sort of looks at, say, compares the risks of a world, with just mitigation and adaptation, where we, exceed 2 degrees C, with a world where we have the same amount of mitigation and adaptation, but we also add in some geoengineering. So a lot of people have pointed out that you can't just look at the risks of geoengineering in isolation. You need to look at them comparatively. So that's one strategy. Another strategy is to think from a kind of precautionary perspective and sort of think about what steps can be taken to when risks are anticipated, to reduce and manage and mitigate those risks. One thing I want to point out is that the risks associated with these technologies are not fixed. They're actually dynamic and modifiable, and it may be possible to take steps to reduce some of the most serious risks to prevent those risks from emerging. So here I'm drawing a bit on work of Katrina McKinnon, who argues that if research on solar geoengineering is going to move forward, it should take a precautionary approach, and particularly a precautionary approach that can guard against lock-in of deployment. So McKinnon's idea is that what we don't want solar geoengineering research to do is make deployment inevitable. We want to avoid a situation where research inevitably sort of ends us up in deployment. Okay, so so the idea here is that if and as research proceeds, we might want to think about issues of slippery slopes and lock-in. So a lot of people have been worried that sort of if we start researching solar geoengineering, then that will inevitably lead to deployment of solar geoengineering. And I think whether this is true, depends on whether the slope is slippery or the slope is not slippery, right? So, I mean, you might say that it's a slippery slope for me to eat a cookie because I might want another cookie and then another cookie out after that. And then all of a sudden I've eaten the whole package. Well, maybe not. Maybe I, after 2 cookies, that's enough sweets for me and I just put them away, right? So the question here is whether research is likely to sort of create some kind of dynamics that are going to accelerate processes toward deployment or not. And the idea of slippery slope is also associated with this idea of lock-in, which is a way, I'll quote Cairns here, lock-in is a way of conceptualizing the outcomes of path-dependent processes and describes how particular technologies may become resistant to change, closing down or constraining possibilities for the development of alternative social technical configurations. These two features can work together. So slippery slopes can lead to lock-in, and certain kinds of lock-in can contribute to slippery slopes. Although I think these two things can also be separable. Like you could be locked in at a certain point in the development of a technology and never sort of go past that point. We can talk more about that later if you want. Okay. I think there are good reasons to think that certain kinds of slippery slopes could operate in the case of solar geoengineering, and therefore to take precautions against them. And this is something that McKinnon also argues. So she says we should pursue solar geoengineering research as a precaution against catastrophic climate change, but we should also take precautions against dangerous deployments of solar geoengineering. And McKinnon further argues that, like, if research were to lock in long-term deployment of solar geoengineering without a plan to phase it out, then this could amount to what she calls reckless endangerment of future generations due to the termination risks that I described earlier. So I think based on these ideas, one insight we can glean is that even if not all forms of solar geoengineering deployment would be bad, and that seems too soon to know, at least some forms of deployment would be bad. And so for this reason, we should embrace, McKinnon argues, we should embed breaks, or what she calls shackling provisions, into solar geoengineering research governance, and then monitor the sort of evolution of research to see if lock-in processes are sort of emerging and to counteract those. Okay. So McKinnon talks a lot about governance of solar geoengineering research as either stimulating research or shackling or slowing it down. But one of the things I want to point out is that, you know, if you're driving, you don't only have a choice between an accelerator and a brake, right? You also have a choice about where to go. So I think there's this further question about what we're steering toward, what we should steer toward with research, and what we should steer away from. And one way to think about what to steer toward and away from is through this framework of anticipatory governance, which the core idea is just looking and acting ahead. So to quote Guston, anticipatory governance is a broad-based capacity extending through society to manage emerging technologies while such management is still possible, sort of trying to avert the Coleridge dilemma. So anticipatory governance recognizes that multiple actors and institutions shape decision processes that evolve over time, and also that early choices can have far-reaching implications, even when those choices aren't actually recognized as choices at the time. So the core message here is that the pathways and processes, what we steer toward with solar geoengineering research and development, really matter. All right. With that in mind, I want to suggest that despite all the controversy over solar geoengineering, many of us might be able to converge on a common goal. And the common goal would be that we should avoid reckless deployment of solar geoengineering. And the intuition behind this is that, like, regardless of whether you think this is promising or we'll need it in the future or we should never use it, I think many of us might agree that certain kinds of deployment scenarios would be quite bad, like deployment that triggers serious international conflict, like World War III. That would be bad. I think many people would agree. Deployment that occurs without really knowing what the impacts or the side effects are going to be, that seems undesirable. And then deployment without any plan for phase out or termination. Those are some examples of deployment scenarios that seem problematic. So for my purposes here, I'm going to understand reckless deployment as deployment that's non-deliberative. It either circumvents or short circuits open and global deliberation. Uninformed, occurs without a thorough assessment of implications. Or uncoordinated, lacking a longitudinal plan for coordinated management and termination. So the question for anticipatory governance then, if you sort of buy the idea that we should try to avoid reckless deployment, is how can we identify and disrupt insidious pathways to reckless deployment? And by insidious, I'm sort of referring back to that idea that sort of choices that we make, even choices we're not really fully cognizant of, can sort of set us down certain paths that have significant implications in the long run. Okay, so to answer this question, how can we identify and disrupt insidious pathways to reckless deployment? I think it's helpful to look at scenarios. And I want to just share a couple of scenarios that I think are helpful. These scenarios are intended to be plausible, but they don't need to be probable. So even if reckless deployment is relatively unlikely, I think it's worth avoiding, and it makes sense to take precautionary actions against it. So a key way to avoid reckless deployment is to consider, take seriously, and steer away from pathways that lead to it. That is, to prevent lock-in of pathways and processes that increase the likelihood of reckless deployment. And to identify and understand these pathways, plausible scenarios should be considered and taken seriously. Okay, so here's the first scenario. The year is 2035. Climate instabilities have been increasing, and the Intergovernmental Panel on Climate Change's 8th assessment report has just been released, indicating that the planet is on track for close to 3 degrees Celsius of warming. Decarbonization is proceeding slowly, while climate adaptation and disaster response are consuming significant time and resources globally. Over the last 10 years, solar geoengineering research has accelerated thanks to funds from a US federal research program, a small number of influential foundations, and academic corporate partnerships. A handful of small-scale outdoor experiments have occurred in the US Southwest under guidelines established in a code of conduct generated by prominent solar geoengineering researchers in 2025. However, the research community on this topic remains small and concentrated in the US and Europe. Scientists from well-established research groups play a key role in a 2025 special report on climate engineering that deems solar geoengineering promising. Few scholars who were not already working on geoengineering were willing to serve as members of the committee that produced this report due to concerns about normalizing what they viewed as a highly risky strategy that could draw attention away from mitigation. With sulfate aerosol injection emerging as the primary approach to solar geoengineering and a growing sense of urgency to address near-term climate impacts, there's increasing momentum toward outdoor experiments. A group of prominent US researchers who have established ties to Congress, to the current presidential administration, and to NGOs supportive of solar geoengineering argue that a large-scale experiment with the potential to create a climate signal is needed to test solar geoengineering. A small coalition of well-connected NGOs who previously helped to advance solar geoengineering research funding drafts legislation to institutionalize a set of modest governance requirements for this experiment that mirror the guidelines for small-scale outdoor experiments. The legislation is appended to a rider on a larger climate science and policy bill, which passes, clearing the way for the climate signal experiment. The experiment then proceeds. In the subsequent year, global surface temperature cools slightly but measurably. The Western wildfire season is the mildest in a decade, and the number of Category 4 or higher hurricanes drops by 25%. Some scientists caution that the effects from a single-year experiment can't be distinguished from climate noise or climate variability. However, the US public is convinced that this is the way out of climate change. The scientists leading the experiment apply to extend it for 5 years, and approval is granted. By the time regional side effects start to become apparent in the global south, publics in much of the global north are convinced that solar geoengineering is crucial to alleviate near-term climate impacts, and there is broad support to continue the program, which by now has become a de facto deployment. Okay, so that's one scenario. Another scenario, and I'll just maybe summarize this briefly, is a scenario in which, similarly, the world has exceeded 1.5 degrees Celsius of warming and is on track to exceed 2°C. The cost of dealing with near-term climate impacts, along with a recession, is reducing the appetite to invest in long-term mitigation. So mitigation is sort of pushed off to the future while we're dealing with near-term concerns. turns out that decarbonization is a bit harder than we expected. And proponents of solar geoengineering swoop in and frame it as a sort of quick and inexpensive solution, using cost-benefit analyses to provide support, even though these analyses can't capture certain not easily quantifiable or long-term risks. The appeal of a cheap and easy way out undermines carbon markets, and mitigation is further undermined, and deployment becomes a self-fulfilling prophecy. So one of the things I want to point out, and I'm close to the end, is that in these scenarios, there are sort of existing dynamics, known dynamics, create pathways that narrow the decision space and narrow solar geoengineering governance options. So one of the things I think about scenarios like this is that even if deliberative processes were put into place near the decision point, like should we deploy, should we not deploy, it's unclear whether these processes could be considered genuinely open or inclusive, given sort of the momentum that already gets in the system. So key insights here are that early intervention is really critical. And to reduce the risk of reckless deployment, we need research that identifies strategies for disrupting these kinds of pathways toward bad reckless deployment outcomes. The scenarios are meant to be illustrative, and then in sort of in closing here, I want to offer some strategies that might help respond to the scenarios and disrupt some of the dynamics that lead to them. So one strategy, and one that I've been pushing for in other contexts, is to diversify the community of researchers and the community of folks who are involved in discussions and deliberations around research, development, governance, and decision-making for solar geoengineering, and increase public accountability. So increase the diversity of the research community, build diversity and accountability in philanthropic funding of solar geoengineering research, which has been a really major source of funding for this kind of research, and increase public oversight and accountability. Second strategy is to tackle what's known as moral hazard, the sort of potential for solar geoengineering to displace mitigation head on. And that might involve broadening cost assessments. This technology is often framed as cheap and easy, but whether something's cheap depends on sort of how broadly or narrowly you count the costs. And so I think one of the suggestions here is to include costs of governance, not just think about the technical costs, and then also to think about ways to prevent a kind of trade-off between mitigation and geoengineering through various pricing strategies. Third strategy would be to really proactively enhance deliberation and work to impede non-deliberative tendencies. This might involve an international sort of ban then vote approach, establishing a deployment ban globally, which could only be overturned by globally representative voting. Domestically, some sort of analogous system could be in place, having a representative citizen jury with veto power at multiple moments within the development of SG research or deployment. And this would tie into what I talked about earlier in relation to exit ramps from a research program that was revealing sort of increasingly concerning insights about the viability of using this technology in a way that would be ethical or just or not overly risky. All right, so lastly, could these strategies work? I don't think any of these strategies is easy to implement, in part because they would disrupt processes that are actually embedded in normal governance and would require changing how governance works. Nevertheless, as I think the two scenarios have illustrated, there are multiple plausible and relatively mundane pathways by which reckless deployment could occur, largely due to underlying dynamics that feed and shape complex path dependencies. So given this, and I want to suggest that anticipatory governance for solar geoengineering technologies requires intentionally identifying and disrupting dynamics that could lead to reckless deployment. And this is sort of a beginning, but I think it would be valuable for others to join in these efforts. And if we wish to avoid reckless deployment, it would be wise to address the underlying dynamics that could take us there now. And that's it. Thank you.
Thank you so much. That was a really wonderful and rich conversation and talk. Thank you. There were a large number of attendees, so we had about 80 people. If you have questions, you could unlock, oh, I see a hand. First question from Andrew.
I wonder, you said quite a lot about what reckless deployment might look like, but what would a reckless non-deployment look like?
Can you say more? I mean, I think I know what you're getting with, but I'd like you to say more. Yeah.
Yeah. Under what circumstances would it be reckless not to deploy? And would that be, say, tomorrow morning, for example?
I mean, well, obviously, I think from the perspective I'm presenting here, deploying tomorrow morning would count as a reckless deployment, and I wouldn't say that that would be a reckless non-deployment. But I think what you're getting at, I mean, maybe one thing to say here is that one of the arguments in favor of like really rapidly accelerating research and maybe pointing research in a direction that's more deployment oriented is that, you know, like some people feel like the impacts of climate change are likely to be so severe that it's worth taking some pretty significant chances on solar geoengineering.
That's follow-up question.
Yeah, that's not my particular view, but I can see why, you know, why there are significant concerns about where we're headed with climate change.
Okay, let me see if there's, let me also check the chat. I didn't see it. Well, I'll jump in with a question while I wait to see some hands. So I like this argument, and I definitely see the need for anticipatory governance. I guess I have two kind of concerns. One is that kind of slippery slope deployment inevitability kind of consideration. And I guess one thing to consider there is that we sort of have an empirical track record, right? So there are other examples, both in environmental ethics and maybe other domains. So I'm thinking of things like the genetically modified mosquitoes, right? So one issue that came up with, you know, environmental concerns was malaria and people, particularly in the equator, and large numbers of individuals dying. So we begin a kind of like scientific investigation into whether or not we could genetically engineer mosquitoes so as not to carry malaria and save human lives. And this always seems like step one in a process where eventually there's going to be participation from stakeholders, and there's going to be some kind of conversation about whether or not to release such a technology into nature. But it almost didn't happen, right? I mean, in Florida, they actually did introduce genetically modified mosquitoes. South America, they did. And I don't know, maybe it's effective. I don't know if there have been any side effects yet or consequences. But it does seem like every time we do develop these sort of new technologies, they almost inevitably get employed. And my fear is that anticipatory governance has a number of hurdles that are going to prevent that from actively, you know, stopping that kind of inevitable employment. And one, I think in particular, is global politics. So I think this is very hard, and this is probably, you know, one of the main stumbling blocks with addressing climate change in general, is that it requires international cooperation at a level we've never seen before.
Mhm,
Um,
mhm,
and the United States has no control over the autonomy of Russia or China or some other country to deploy such technologies if they decide to deploy. So wouldn't that kind of anticipatory governance require structuring a whole new kind of international stakeholder model, which gives some third-party organization control over the autonomy of political decisions that countries make? And if not, how do we prevent some other country from implementing, geoengineering technologies, other than like what other political levers we might have in terms of like, trade bargains and other kinds of mechanisms. But it hasn't worked with cutting carbon emissions. Again, why think that it's going to work? So I guess my two-part question is, we've seen the slippery slope happen over and over again.
mhm,
Cloning technology becomes possible, then we do it. Genetically modified living organisms becomes possible, and we do it. Genetically modified organisms that could affect the environment become possible, we do it.
mhm,
Genetically modified organisms to fight, disease become
mhm.
possible, we do it.
Yeah.
And again, we don't have any control over South American countries who decide we want to introduce genetically modified mosquitoes into the environment. So how do stakeholders, and it is a global community, how do the global community of stakeholders exercise what you called like that veto power?
Mhm,
Like,
mhm.
how would
Yeah,
that actually work? And
yeah,
we
yeah.
can't have a practical model by which that would work. Aren't we going to kind of, I mean, isn't it likely, like, and it's an empirical question, but isn't it likely to see something like that slippery slope into inevitable deployment? Sorry, that's a long, complicated question. But
Yeah. So I don't know whether a slippery slope to deployment is inevitable, I guess. But what I'm saying, I don't think that there's just one inevitable pathway from where we are today to sort of the worst forms of deployment, right? So I'm inclined to think that it's unlikely that that there's going to be sort of a total moratorium on research on this topic. And if research is going to continue, then my suggestion is that we think about how research is structured, and governed such that the worst forms of deployment are less likely to eventuate. Like I don't think that there's any strategy that's going to like make it the case that we can be confident that deployment won't happen or that bad deployment won't happen. But I guess I am taking sort of a ameliorative approach and saying there are things that we can do now that are going to make it less likely that the kind of forms of deployment that many people would agree would be undesirable are going to happen. So that's basically the strategy. It's not saying that this is going to be solve all the problems, but I mean I would
yeah,
say that I do think, and you said also, I guess, like we're going to need different kinds of ways of doing things, and yeah, like
yeah, yeah.
sometimes people say when in the governance discussion, some people are saying like sometimes people say like why should we have governance for this like when we don't have governance in these other domains of scientific research, like why I'm saying, well, maybe it's not a good thing that we don't have governance in those other areas. So just because like we don't do it well in one place doesn't mean we shouldn't do it well in another place. And I have some degree of hope because I actually have seen the conversations over ethics and governance evolving in such a way that I've seen some shifts toward like taking ethics more seriously, for example, as an element of the conversation. I think there's much more attention. There's quite a bit of attention to like epistemic diversity, for example, and to the problem of having research concentrated in just a small number of wealthy countries. So, like, yeah, I think the kinds of global governance mechanisms I gestured toward at the end, I think, yeah, hard. Like, but maybe because things are hard, doesn't mean that we shouldn't sort of think about,
Yeah.
we might go there.
There's a question here. I'll read it. I don't know if maybe they could jump in if they want to add anything to it. It's a question from David. Are there discussions of the ethics of not acting rapidly on mitigation, even if it eliminates negotiations on a just transition? So I don't know, is David there? I could unmute you if you want to talk more, but
Could you maybe read that one more time?
yeah. So it says, are there discussions of the ethics of not acting rapidly on mitigation, even if it eliminates negotiations on a just transition? So even if it eliminates.
So I'm not exactly sure how to interpret the question. I think actually
Yeah.
some of the arguments for not acting quickly on mitigation or for slowing down mitigation in some contexts actually has to do with promoting a just transition. Because it's, you know, it can be, there are near-term costs to changing infrastructures, changing energy sources, and so on. So some people have argued that, you know, certain like poorer countries shouldn't have to proceed as quickly on mitigation because they need space to develop, or they need technological assistance, or so on. I don't really know. Yeah, I'm not sure about how the just transition part of the question as phrased fits in.
Okay, yeah. Anyone have a question? Just, you could either raise your hand or. Oh, wait, David's here. I could unmute him, so hold on. All right, David, I unmuted you, I think.
I apologize. I typed too quickly. My question relates to the fact that from one point of view, negotiations on elements of the just transition, including loss and damage and other sticking points that are tied up because of the need for consensus at the UNFCCC negotiations, can, from one perspective, be slowing down an agreement that might be available to the major emitters to move more quickly. Recognizing that Paris is pretty much as far as any of the major emitters are willing to go necessarily. Are there ethical arguments in favor of ignoring discussions of the just transition in order to mitigate as rapidly as possible in order to spare future generations of the impacts of larger climate change? And I should note that I'm not necessarily supporting that argument. I'm just curious to see whether that's discussed amongst climate ethicists. Thank you.
Yeah. Yeah. I mean, I think there are discussions of, I would say yes, right? So, I mean, and one of the places where this comes up is like in discussions over feasibility, you know, and so does it make sense to go for the most feasible solution, which in this case, you know, in the example you gave might be a solution that's, or a response or an approach that's acceptable to the most powerful actors, like in order to get something done, even if it has costs, you know, negative costs, or even if it's unjust in certain ways. So yes, these things are, there's a book by Steve Gardner and David Weisbach that on debating climate ethics that sort of takes two different sides on that issue. And it also comes up when people argue that, you know, all these discussions of, I mean, this comes up in the solar geoengineering discussion as well, that like, and maybe this is something that Andrew Lockley was getting at earlier, but that, you know, discussions of research governance and ethics and like the establishment of certain codes of conduct or procedures are just going to slow down research, and research is very urgent. And so in a way, like certain ethical considerations might need to, I mean, this is also sort of the emergency framing too, like, if in an emergency, it makes sense to just plow forward and set aside some of the ethical considerations. But I think, on the other side of that, the people who are, those who are going to be affected by a lack of, sort of just inclusive processes, might argue, that justice should not, reasonably, I think that justice shouldn't be set aside, and that these arguments are often used to kind of ignore or bypass their interests.
Okay, we have a question from Eric Peterson. Let me go ahead, Eric.
Hey, how's it going? Marion, thank you so much for your talk. I really appreciate it. It's not an area I'm very familiar with, so but it did get me thinking about sort of an area I do study, and that's the imagination. And I guess I'm just curious, do climate ethicists or those who work on environmental ethics, do they engage at all with those who sort of do ethics and sort of talk about moral imagination? Because it seems that obviously one of the hardest parts when you're trying to convince certain stakeholders, I mean, we're talking about future states, and it turns out that humans just are notoriously bad at imagining states of affairs or imagining how they might be affected. So really, I was just curious if there's any interaction, or maybe a suggestion that there could be, because there's really neat research about imagination being a skill. So then there could be some sort of collaboration, I just think, with scholars who do that work, or who focus on moral imagination. So just any thoughts?
Yeah, no, that's actually a great question and great suggestion. I mean, I do think the scenario work involves a kind of imagination, like sort of envisioning potential pathways or potential possibilities, and how those might unfold, and sort of entertain. One of the things that's come up actually quite a bit in some of the recent literature is that the scientific modeling of geoengineering tends to sort of focus on figuring out, like, what would be the optimal way to do this, what would be sort of and focuses on sort of ideal conditions, and the real world is not ideal, right? So so there's been a push to sort of encourage thinking about, like, the complexity and how things might not work in the sort of rationalistic, scientists favored pathway scenario. There's also a really interesting book by Holly Buck called After Geoengineering that I think is quite actually imaginative, and sort of thinking about geoengineering in a sort of broader context of imagining climate futures. It includes some sort of, I think it's some sort of fictional scenarios, and it has a kind of, I don't know, choose your own adventure almost kind of feel to it. So I would recommend that book. But if you have ideas, I mean, about sort of how to bring the work that you're doing on imagination, or like if you have suggestions for things for me to read, or how to bring those things into conversation, do feel free to follow up with an email or something. I'd be curious to think more about that.
Yeah, great. Appreciate
Thank
that.
you. There's another question from James. Let me just say, you mentioned Stephen Gardner twice. He's going to be a guest speaker, part of our seminar series next semester. So keep an eye out. James, I'll allow you to talk there. Yep. Hi, James.
Hello, hi. Good afternoon, Marion. Thanks for your talk. I just actually wanted to ask you if you could elaborate on the importance of diversity. You mentioned that on one slide, and specifically, what risks are we running with the lack of diversity? So essentially, basically, what are the literature on epistemic diversity, and if you could give a concrete example of how?
Yeah.
Yes,
Sure. Yeah. Yeah. I mean, I think, as I said, I do think this has improved somewhat, but I think some of the, one example would be that some of the models, especially early models of solar geoengineering, focused primarily at the global scale, like thinking about like how would, global mean surface temperature change, or how would global average precipitation change under a certain approach to geoengineering. And I think one of the things that has emerged in the conversation is that like regional impacts really matter quite a bit, because we don't experience temperature as like as humans or ecosystems don't experience global mean surface temperature. We experience like the temperature where we are, right? So if it's like +5 degrees C in one hemisphere and -5 degrees C in another hemisphere, the average is like 0, but that's probably pretty disastrous for the planet, right? So I think the epistemic diversity, has, having more researchers involved has increased from different parts of the world and from different perspectives, has and can lead to asking sort of different sets of questions and paying attention to different variables, than might be the case if we just had sort of, a narrow epistemic community without a lot of diversity. And I think some of the research has also suggested that, like, I don't know, there's been some social science research, for example, on folks in climate vulnerable regions that has suggested that a kind of reluctant acceptance of, and I'm thinking this is work of Wiley Carr, of research going forward, but the chief concerns being about agency and the idea that, people are saying things like, it's really scary to imagine like, people in a small number of countries controlling our climate. So I think there are considerations that maybe, here in the US, I think there's sometimes a kind of background assumption that we would have a significant role in deciding whether this kind of technology would be deployed or not. And I actually really think that frames, I think the kinds of research questions we might ask from that perspective might be different from the kinds of research questions we might ask if we knew that we were unlikely to be in control of decisions about deployment. Hopefully that helps a little bit.
Thank you. Thank you.
Thank you. I have another question. I'm curious if you think the especially with regard to governance questions, if the privatization of a lot of these industries poses any kind of unique problem. So I'm thinking, for example, like the United States essentially outsourced its space program, right? Like no longer is NASA sort of the taxpayer funded space program that it used to be. Now we have Elon Musk and other billionaires independently and privately controlling sort of satellite deployment. And that raises all kinds of issues. Like we just saw one in Ukraine with the control of satellites once that is privatized. Do you think that, private capital is probably going to want to invest in geoengineering if they see it as a kind of market? And if they see potential like government contracts and such available, there may be research and funding that causes private industry to sort of take the lead. Yeah, I guess one good question I have is like, do you want, as part of this sort of anticipatory governance, do you even think we might need an anticipatory regulation? Like put in place now regulations that give governments control over privatized companies, not preemptively deploying without permission from governments or international bodies.
Mhm.
Because we didn't do that in the past. We didn't do that with satellites. We didn't do that with the space program. And I think we're seeing even national security risks sort of popping up now because we're at the whim of Elon Musk. If we want to
Yeah.
ask him to point a satellite in a particular direction and his political allegiance doesn't line up with our interest, he says no, and we have no control over that. So do you think that, you know, governance is one thing, but also like regulation is another, and maybe we need anticipatory protections put in place now?
Yeah, I do. I mean, so, you know, and there has been discussion of like, you know, intellectual property and patents and sort of, you know, not allowing privatization of intellectual property in this domain.
When you have finished recording, you may hang up.
Sorry, I'm gonna mute. That was someone. Yeah. go
Oh,
ahead.
it's okay. I also, so yeah, and I think, so yes, I guess, I mean, I'm not, you know, there are probably others who are much more expert in me in thinking about like that specific domain and what kinds of regulations would be appropriate. But for a long time, and, you know, and maybe this goes back to why imagination is important, or why looking at sort of parallel cases, as you're suggesting that we do, is important. For a long time, there was this sort of theme in the discourse around solar geoengineering that like it's not the kind of technology that could be privatized or would be privatized. It doesn't have the right kind of incentive structure, et cetera, et cetera, et cetera. It's sort of like a global public good, like yeah, and potentially, if you want to think about it that way. But then actually this, you know, a lot of people would say we shouldn't pay attention to this at all, but these two guys started this company like Make Sunsets, which basically is predicated on the idea that you can sort of buy climate offsets. You can pay them and they'll launch a balloon full of sulfur dioxide to do like, you know,
Yeah,
mini sunlight reflection. Like, and most scientists think that this is sort of a joke. It's not going to have any impact on the climate and it's not scientifically well informed, etc. But like, I actually think it was a very interesting sort of like, I don't know, like proof of concept. Like, you know, it's sort of it counters the narrative that like no one will ever try to do anything commercial in this sphere. Obviously, people are going to creatively try and invent ways to do this. So yes, I think anticipatory governance of the kind that you're mentioning is probably important to think about.
Thank you. I don't see any more questions, so maybe we'll let you off the hook. Thank you so much for being here. That was a really enjoyable talk. And if anyone has any additional questions, you could contact me and I could potentially put you in contact with Marian. So thank you. Thank you so much for being here.
Yeah, thanks for having me and thanks to everyone for being here and for listening. I appreciate it.
Yep. And I'll send you a recording and I'll email you. So
Sounds good. Thank you.
Thank you very much.
Yep, bye.